For as long as humans have walked on this earth, we have stared into the black expanse of space, wondering where our place in the universe was and why we are here. The rhythm of the moon's phases has guided humanity for millennia, but Galileo was the first to point a telescope towards it and identify its mountains and craters. Not just that, he saw that those distant heavenly bodies had moons of their own, a discovery that shook the religious world's view of our place in the universe. Fast forward 300 years, and we've landed 12 men on our moon, an achievement that was largely driven forward in a world living in the shadow of a threat of global nuclear war. Since that threat has subsided, our race to expand into space has waned. The Mars Society put it best with their founding statement: "Civilizations, like people, thrive on challenge and decay without it. The time has passed for human societies to use war as a driving stress for technological progress. As the world moves towards unity, we must join together, not in mutual passivity, but in common enterprise, facing outward to embrace a greater and nobler challenge than that which we previously posed to each other. Pioneering Mars will provide such a challenge. One man has embraced that challenge like no other, and his name is Elon Musk. Today we're going to investigate, how will SpaceX get us to Mars?" Elon Musk's ultimate goal is to reduce the cost of space travel. He believes if he can get the cost of a ticket to Mars down to around $500,000 USD, the overlap of people who actually want to go to Mars and the people who can actually afford it will be great enough to fund a Mars colony. The most efficient way, that is, the one that uses the least amount of fuel, to get to Mars from Earth is with the Hohmann transfer method, named after Walter Hohmann, who first proposed the idea in 1925. With this method, you wait for Earth to be at its closest point to the Sun and then launch. Mars needs to be about 44.4 degrees ahead of Earth, so that Mars will be at its most distant point from the Sun when the vehicle arrives. This alignment happens once every 26 months. This is not the shortest or the fastest path to Mars, but it requires the least amount of energy input. When getting the cost of travel down, this is the deciding factor. As I mentioned in my last video, the space shuttle could transfer 1 kilo to low Earth orbit for about $18,000. The Falcon 9 can do the same for just $2,700, and SpaceX is continuously working to reduce that cost. Let's take a look at the Falcon 9's launch sequence and learn some of the ways SpaceX has reduced the cost of operation. The Falcon 9 first stage is powered by 9 Merlin engines. These engines have the highest thrust-to-weight ratio of any booster engine ever made at 155:1. This means the engines can lift more with less fuel and do it faster. At launch, the 9 engines produce 7,900 kilonewtons of thrust, lifting the 550-ton rocket off the ground and gradually accelerating it to 5 times the speed of sound. This section, called the interstage, houses another Merlin engine that is designed to work optimally in the vacuum of space. The first stage now separates about 75 kilometers above our planet's surface and reveals the second stage engine. It's interesting to note that the interstage remains connected to the first stage after separation. This was not the case for the Saturn V, as the interstage needed to wait for the engines of the second stage to fire before separating using pyrotechnic charges. This ensured a clean separation, as there were worries that the interstage would collide with the engines as it separated, due to clearance issues. This is not a problem with the Falcon 9, making the interstage reusable and again saving money. The Merlin engine of the second stage is designed to be shut down and restarted multiple times to deliver the payload to the appropriate orbit, or increase the velocity enough to perform the Hohmann transfer to Mars. The payload is stored inside this composite fairing, which is big enough to fit a school bus. When the time is right, the fairing splits in half and drifts away from the second stage. The payload is now released into orbit around Earth. Meanwhile, the first stage has begun its descent back down to Earth. Cold gas thrusters fire to flip it around. Once this maneuver is complete, the engines will fire again to bring the speed down for re-entry and give an appropriate trajectory to reach the landing site. Upon re-entry, the grid fins deploy, which provide aerodynamic control, allowing it to steer. These are fantastic little devices that provide excellent control at supersonic speeds. This mesh structure provides a huge amount of control surface area in a small amount of space, which allows them to be easily stowed away during launch to reduce drag. Grid fins are also much shorter than conventional planar fins, so they generate less hinge moments, meaning they need smaller motors to control them in high-speed flow. As the first stage descends closer to sea level, the cold thrusters, grid fins, and Merlin engines work together to control the precise landing on the drone ship barge. The reason SpaceX uses this barge is another cost-saving measure. The Falcon 9 launches from land towards sea for safety reasons. When the first stage separates, it's over open ocean, and if it needed to return to land, it would need to slow down, turn around, and use more fuel to get back to where it started. Instead, the drone ship can place itself at the predicted landing zone and wait for the first stage. This way, the Falcon 9 just needs a little bit of extra fuel to slow itself down to land. Most people see SpaceX's true innovation in their reusable rockets, but their innovation in the manufacturing field is just as significant. SpaceX was the first space company to employ a method called vertical integration to manufacture their rockets. This means that SpaceX designs and manufactures nearly all of its components itself. The Merlin engines, the aluminium lithium fuel tanks, the composite fairing for holding the payloads, the Dragon spacecraft, the flight computers and the coding that goes into them. They are all designed and manufactured by SpaceX. Comparing this to the space shuttle, Rockwell developed the orbiter, Lockheed Martin developed the external tank, and ATK developed the solid rocket boosters. Each of these companies have their own subcontractors too. This adds a huge amount of cost onto the final price tag. Each subcontractor adds a markup percentage to their selling price in order to make their own profit. Manufacturing everything yourself eliminates all of these price markups. It cuts out the middlemen, like buying popcorn as kernels and cooking them yourself rather than buying them from the cinema for $10. It has the added benefit of allowing you to have full control of your quality control and creates an efficient product development system. All of your employees can speak and collaborate to improve and develop new designs. Elon insists on open plan offices to remove any communication barriers. He himself works in a cubicle. This creates the perfect environment for continual innovation, and if we want to get to Mars, that is going to happen. So you may be wondering, what's next for SpaceX? They will be launching their Falcon 9 Heavy variant at the end of the year. According to SpaceX, the Falcon 9 can currently launch 1 kilo to Mars for $15,400, but the Heavy variant can launch 1 kilo for about $6,600. The average American weighs 80 kg. Ignoring all other costs like how you'll live on Mars or how you'll survive the journey there, the raw price for a one-way trip to Mars will be about $500,000. Musk aims to bring the price for a round trip, including all other expenses, to Mars, down to $500,000 total. In 2010, SpaceX presented concept designs for future heavy lift rockets. That will help towards that goal. They're also planning to replace the 9 Merlin engines of the Falcon 9 with one incredibly powerful engine, dubbed the Merlin 2. That will increase the thrust to weight ratio even more. I for one am really excited to see what Elon Musk and his incredible employees have in store for us. Thanks for watching. As some of you may know, I quit my job earlier this year with the ridiculously ambitious goal of growing this channel so that I can spread the incredible work that engineers do all over the world. I never thought I'd be able to do it full time for long, as I've been eating away at my savings, but thanks to this week's sponsor, I can keep doing it for a little while longer. So thank you to the Great Courses Plus for helping real engineering exist. If you enjoy my videos, you'll definitely like the Great Courses Plus. They have over 7,000 different lectures from world-renowned educators. There's a huge range of topics with loads in engineering and technology, or you can learn about photography, chess and cooking. You can learn at your own pace, without tests or exams. My personal favourite course so far is the Science of Information, which teaches the science and history of how information technology has transformed our world. You can check that out with a free month trial by going to thegreatcoursesplus.com/real engineering. Once again, thanks for watching. If you'd like to see more or support Real Engineering, the links for my Patreon, Instagram, Facebook and Twitter accounts are below.